Hi everyone, I'm Allie Cody and I'm doing my project on sexual dimorphisms in body proportions of Masai giraffes and the evolution of the giraffe's neck by Douglas R. Cavener. So Douglas R. Cavener is currently a professor at Penn State. He studied at Pasadena College for his bachelor's degree and then went on to Brown University for his master's and then ended up at University of Georgia for his PhD. He mainly researches molecular biology, cell and developmental biology, genetics, and evolution. He's also been awarded the Theodosius Dobansky Prize in International Society for the Study of Evolution and the Fellow of the American Association for the Advancements of Science Awards. So, some background on his paper is sexual dimorphism is strong in giraffes due to the significant difference in size, neck length, and height between males and female giraffes. And a hypothesis that was pretty well known for this was called necks for sex. And it was just a hypothesis that claimed that male giraffes with longer necks were more likely to win fights for mating advantages. But this hypothesis has not taken the body proportion in comparison to neck length in males and females into account, which may be important for deciding whether males or females have longer necks overall. So the hypothesis, Dr. Cavener studied many aspects of giraffes, but he was specifically focused on whether male giraffes do not or do have proportionally long necks compared to females, and if the skeletal proportions are sexually dimorphic, and also if these proportions are consistent between giraffes that are in the wild versus captive giraffes, like in zoos. And the methods that he used were that a lot of captive giraffes across North America in zoos were studied, and then they also studied wild giraffes in Tanzania to compare proportions. But all of the giraffes studied were Maasai giraffes. And then they measured neck, trunk, foreleg, hind leg, and neck width for proportions and just kind of calculated percentages. This is a good little graph of just where all of those aspects are on the animal, in case you're wondering. And then the results of this experiment were that juvenile giraffes had the same proportions between males and females, but once they hit puberty at about age 3, that's when the dimorphisms started occurring. And then they started kind of showing more male versus female traits. But overall, female giraffes have longer necks in comparison to their height and legs, which contradicts the necks for sex hypothesis. And males have proportionally longer forelegs and higher withers or shoulders, but a thicker and stronger neck than the females do. So this information supports a more revised necks for sex hypothesis because with stronger necks, there's still a mating advantage when it comes to fighting for a female because a thicker, stronger neck probably more likely to win that fight. And the results of this experiment, this is a table just showing the captive versus wild males and females. So it was revealed that the same proportions are common between captive and wild giraffes, but the females tend to have longer necks with shorter trunks and legs, and then the males have longer legs and trunks, but actually shorter necks. And there are instances where male captive giraffes would kind of have more female-like proportions, so they ended up having shorter legs and a shorter trunk and a longer neck. So this graph kind of just shows the ratios and everything. So it's pretty similar between female captive and female wild, and then male captive and male wild. Of course, there are some outliers there as well, though. So the conclusions from this study are that the next for sex hypothesis is not correct necessarily, but a revised version is closer due to the male specimens having stronger, thicker necks rather than longer necks. And then male giraffes tend to have longer legs and trunk and a shorter neck proportionally, while it's opposite in females because they do have a longer neck overall. And then captive and wild giraffes have similar proportions and features, but there is occasionally some differences in captive giraffes due to the lack of sexual competition, likely. And then here's my bibliography. So thank you guys so much for watching my presentation. My discussion question for you guys is why could captive males show more opposite sex body proportion phenotypes than wild males? And what does this reveal about how selection maintains morphology in natural populations? Thank you.